United Launch Alliance, or the ULA, which is basically the United States' answer to the ESA, sort of, except for it's private. It's a joint venture between two companies, Lockheed Martin and Boeing. And those two companies used to compete for U.S. space contracts, and finally they were just like, screw it, whatever, let's just work together, this is not productive. So they started a joint venture, the ULA, which some of you I'm sure have read about for your apps, probably no surprise at this point. But they essentially provide spacecraft launch services to the government. They do stuff for the Air Force through the Department of Defense, and they also work with NASA. So NASA doesn't have their own launch service. They don't have their own stuff. They call up the ULA and they're like, hey, we need to put this thing in space. What do you think you can do for us? So the ULA has 3 expendable launch systems: the Delta II, the Delta IV, and the Atlas V. Now they also use the Falcon 9, which is a reusable launch system, which I guess is kind of interesting, except for it's almost never reusable because it usually burns up and falls in the ocean. But they launched their operations at 2 places: Cape Canaveral in Florida, which is where I Dream of Jeannie was. You guys should know that show. Anyone ever watch I Dream of Jeannie? Right at the Cape Canaveral. Yeah. There's not really a genie there, but that was the most interesting thing I could think to say about Cape Canaveral. And Vandenberg Air Force Base in California. So there's no place where it's just like, this is NASA, and everything happens here, right? Spread out their operations to nice warm places around the United States. So the Atlas V. The Atlas V. It's a medium-heavy launch vehicle, meaning they can launch medium-heavy things. And it's an EELV. I'm sure you guys have encountered this term throughout your research. I feel like someone asked me what this was last night in lab. Maybe not. Maybe I just hallucinated that.
Someone did.
Was it you?
I think so.
You think it might have been you? You're not sure anymore? Alright, that's fine. So here's your definition, Mark. It is an expendable launch system program of the United States Air Force intended to assure access to space for the Department of Defense and other other United States government payloads. So right now they're just expendable launch vehicles. They're pretty cost effective, they're pretty safe, and they're attempting to do what they call human rate them, which means make them safe to take humans to space. So for apps like the one that my lab is writing, like restart the Constellation project, we need people in space, we need moon exploration. A lot of people say a better alternative than restarting the Constellation project is just to give money to this, because this is our best hope to human rate launch vehicles, and we don't really need the Constellation project. Obviously, I disagree, but that evidence is actually pretty good. Go cut a counterplan or something, I don't know. There's also the Delta II, which is sort of on the way out. It's pretty old, but it's an American space launch system. It was originally designed and built by the aircraft company McDonnell Douglas a long, long time ago. Part of it has been in service, or it has been in service since 1989, which I was alive then, but I don't think any of you were. So it's been a long time, at least from your perspective. They recently retired it. And the last mission is set for later this year. In 2011, it's going to take a lunar exploration capsule with it, and just kind of, that's it. It's over. So if you wanted to see it, your last chance is going to be in December, unfortunately. So the updated version from the same family but different is the Delta IV. Like the Atlas, it's an EELV, which apparently the Air Force is super jazzed about right now. They're all about the EELV. So in 2003, Boeing pulled it from the commercial market, so it doesn't take up commercial telecom satellites anymore, because people just didn't really want to use it. Satellites that telecom companies are just whatever, we're not really huge in the Delta IV, so they're not really used for commercial purposes. By not really, I mean not at all, because they cost a lot of money as well. Also in 2005, Boeing said that it might return into commercial service, but there's been no further announcements there. I think it's probably just too expensive. But the Delta IV is a lot like the Atlas V in a lot of important respects. It's a medium heavy payload launch vehicle. It can pull heavier stuff than the Atlas can. The Falcon 9. Falcon 9. This is some like evil James Bond villain shenanigans. It sounds actually awesome except for the fact that it hardly ever works. But it has a cool name. The Falcon 9 is manufactured by SpaceX, which already sounds like an evil supervillain company. But it is an American space transport company. It's founded by the guy who invented PayPal, because he obviously knows all about space from inventing PayPal. Clearly not, but whatever. It developed the Falcon 1 and Falcon 9, and his goal was, hey, you know what, I invented PayPal, I'm obviously a genius, I can make a reusable launch vehicle, because why not? Sure. How hard can rocket science really be? Turns out real hard. But the first stage has parachutes, which is kind of interesting because most launch vehicles just kind of let stuff fall, because they're never planning to reuse it. Who cares if it gets banged up? And it was intended to be recovered to demonstrate how to reuse it. But so far, they failed to recover any of the stages from their test launches. The stages are expendable for the initial launches, and by Flight 6, the first stage is intended to be recovered, but that hasn't happened. So any of you who are interested in reading information about reusable launch vehicles, it's really, really hard. And I looked last night. It's really, really hard to find cards that this technology isn't anything but its infancy. But here's a consolation quote for you. This is what he had to say about it. He's like, oh, well, on Flight 6, we think it's highly likely we'll recover the first stage, which is just like about, I don't know, 25% of the rocket. When we get it back, we'll see what survived through re-entry, what got fried. That doesn't sound good. Carry on with the process. And that's just to make the first stage reusable. It'll be even harder with the second stage, which has got to have a full heat shield, and it'll have to have deorbital propulsion and communication. So it can't just fall off in space. It actually needs propulsion systems to free it from the Earth's orbit and propel it back down to Earth. Yes?
Can you go back one slide?
Sure. You like the Falcon 9? The miserable failure of the Falcon 9. Although I do kind of want to work for SpaceX. That's just kind of like one of those companies, you work for them, that sounds pretty awesome. But that's just me. You still clapping? Oh, sweet. Alright, we're going to move on. You can give these slides to me if you want them. Brett can post them. That's what he does. Alright, so if for some reason, after listening to my riveting lecture about launch vehicles, you would like to see a launch for yourself, you can do that if you want to go to Florida. And since most 15 to 18-year-olds are in the business of booking their own trips, I'm going to give you all of this information. There's only one more space shuttle launch left. Most of you will still be at camp when this occurs. July 8th at 11:26 a.m. and then no space shuttles again ever.
We should watch it.
We'll take a field trip to Florida? Yeah. I'm down, but gotta ask the boss. Kidding. And you can all pay for my trip too, right?
Yeah.
Yeah? Alright. I will take that to the next staff meeting. But it's the Space Shuttle Atlantis. If they do put it on television, I assume that we will probably watch it, although it's not nearly as exciting as you might imagine. Has anyone ever seen a space shuttle take off? I mean, it's kind of cool, but really it just looks like something going into space. And stuff falls off of it, and then it's gone. Which I guess is interesting. Hope it doesn't blow up or anything. That would not be cool. It would be a very expensive error. Alright, settle. Commercial launch. Commercial launch is contract launches for companies like telecommunications companies that want to have satellites in space, but as most telecommunications companies have the problem of not having any launch vehicles. So they do contract launches, and the ULA is actually kind of falling down on the job pretty spectacularly. They're not super interested in contract launches. They're not totally capable of contract launches. Their equipment is expensive. It's not in high demand. So the ULA does not make a ton of money off of contract launches. Now I say the ULA does not sell launches. Lockheed Martin and Boeing do on their behalf. And the U.S. government doesn't sell launches either. So don't get that into your head. But the ULA needs funds from the government to bring monies to them to support developing innovation so that they can sell launches. Because without government money, they're not going to be able to build low-cost launch vehicles that can launch like commercial satellites. It's just not going to happen. Because it takes a different kind of satellite, or not satellite, different kind of launch vehicle to launch a telecom satellite than it does to launch something that needs to go to like Mars, right? Depends on where they focus their research. But right now they just kind of don't feel like doing anything but cool space stuff, which I understand, because I kind of agree. Alright, so propulsion. What is propulsion? No one knows? Awesome. Yes, literally it is propelling something. Who said that? Congratulations. Alright, literally it is propelling something, which seems like an easy thing to do for like a car, or even a bus, or even an airplane, but for a rocket, it literally is rocket science. So, spacecraft propulsion is basically any method that's used to accelerate a spacecraft, an artificial satellite, anything like that, and get into space. Most of them are propelled this way. And I've included this very helpful diagram, which totally looks true to life. It's definitely what propulsion looks like. Kidding. But it's an artist's representation that can show you the green is slow, the red is fast, and it forces the gas from the back of the vehicle at a very high speed through a supersonic nozzle, which kind of slows it down and then creates the force, the lift. Just so you know, it's called a de Laval nozzle, and it's actually not something that was developed for rockets. It's actually a very old technology that just happens to still work very well. It was developed in the 19th century by this guy named Gustav, which is an awesome name, de Laval, for use in steam turbines. And we still use it on rockets. So that's kind of awesome. However, there are significant downsides to this form of propulsion. All current spacecraft use chemical rockets. They use either a propellant or a solid fuel, kind of like the same thing that you would put in your car, to achieve combustion. So really we're kind of low-tech with the way that we actually propel these things into space. Although some of them have used air-breathing engines on their first stage. Like I said, the first stage is still within the Earth's atmosphere, so you can do some stuff that's a little bit less tricky and less expensive. Like an air-breathing engine, it's just a combustion engine that uses the oxygen in the atmosphere to like oxidize or like burn the fuel rather than carrying an oxidizer. Because attaching an oxidizer to a rocket is mucho expensive, more parts, way hard to do. So, at the very least, a cost-saving measure is to add the air-breathing engine to like stage 1 of a 5-stage launch vehicle. That said, it can, not that specifically, not the air-breathing engine, but just the propellant system, the one we have now, results in a better specific impulse. The specific impulse is just the change in momentum per amount of propellant used. So, theoretically, there are some advantages to the way we do things right now. That said, the effectiveness. The purpose of a propulsion system is to change the velocity, or I guess I think it's like rate times time, you're nice, you tell me, of a spacecraft. So the goal of the propulsion is to create an impulse. And like I said, these impulse calculations have to be super, super specific. If you're off by even a little bit, then something either crashes to Earth or goes hurtling back into space. So we need to be very, very precise. It must overcome the Earth's gravitational pull, and it's going to leave the Earth's atmosphere. Like I said, we have to have what is called escape velocity, which basically means it has to be going really, really fast so the Earth doesn't pull it back. And again, with the orbit, it's really, really hard to place something into a specific orbit. Can't be going as fast, it has to be super, super precise. So even newer launch systems, like the theoretical ones I'm going to talk about, aren't so good at that. So some conventional methods, the stuff we use now are reaction engines. A reaction engine is just an engine which provides propulsion by expelling reaction mass. And essentially what reaction mass is just forcing mass and energy back down to the Earth. So it essentially presses down on the Earth and then, in effect, presses up on the rocket. So it's essentially kind of like